Good day everyone, welcome to all. My name is Sachin Ahankari, working as Assistant Professor in Narasimha Reddy Engineering College in ECE department. So today in this session we will see few other performance parameters or electrical parameters uh, in the op-amp. So output voltage swing. So output voltage swing is nothing but the maximum peak to peak output voltage which is available at the output of op amp. So as we are applying plus or minus 15 volt at the VCC and VEE, so zero point 0.9 times VCC or VEE will be the maximum voltage at the output. So here for 15 volt you will get plus or minus 13 volt at the output. So the output voltage swing, that is maximum peak to peak voltage of 26 volt is available at the output of op amp. So here op amp gets saturated at VCC and minus VEE. Practically it is saturating at 0.9 times VCC and 0.9 times VEE. So this is about output voltage swing. The another electrical parameter, performance parameter or characteristic of op amp is output resistance. So it is the equivalent resistance that can be measured between output terminal of op amp and ground. So it is the equivalent resistance. So if you connect the ohm meter, one terminal of ohm meter should be connected to the output terminal, while other terminal of ohm meter should be connected to ground, and whatever the resistance is counted by your ohm meter, that resistance is called as output resistance, and it is denoted by letter R0. And for op amp 741 the value of R0 is 75 ohm. So this is a this is about output resistance. Now the input voltage range. So it is a maximum range of input voltage that can be applied simultaneously to both the inputs without causing cutoff or saturation of amplifier. So generally the value of input voltage range is plus or minus 13 volt. So you are applying the plus or minus 13 volt so that your op amp is not going to be saturated. So it is a maximum range of input voltage that can be applied simultaneously to both the inputs without causing cutoff or saturation of amplifier. The next electrical parameter is power supply rejection ratio. It is also called as supply voltage rejection ratio, or it is also known as power supply sensitivity, and it is a ratio of change in input offset voltage to the change in input voltage. So here the PSRR is delta VIO divided by delta V, that is change in input offset voltage to the change in supply voltage. The value, typical value of PSRR is 30 microvolt per volt, and if the value lower is the value of SVRR in microvolt per volt, better is the op amp performance. So your PSRR or SVRR or PSS, power supply sensitivity, or supply voltage rejection ratio or power supply rejection ratio, the value should be as less as possible for better performance of op amp. The next electrical parameter is slew rate. So the slew rate is defined as it is a maximum rate of change of output voltage per unit time, and it is expressed in volt per microsecond. Uh, the slew rate indicates how rapidly the output of op amp can change in response to the changes in input frequency. The slew rate changes with the change in voltage gain and normally specified at unity gain bandwidth. So here because of the lower slew rate for 741, the slew rate is 0.5 volt per microsecond, and due to lower slew rate uh, you cannot use the op-amp in high frequency applications, especially in oscillators, comparators, filters. You cannot use the op-amp in high frequency applications if the slew rate is less. So here the newer op-amps like LF351, MU-A771 and MC34001, they are having the higher slew rate of 13 volt per microsecond are available in the market, and one of the uh, uh, op-amp which is having the slew rate of 70 volt per microsecond is LM318, so which is also available in the op-amp. These are the newer op-amps which are having higher slew rates. So due to the slew rates, you cannot use the op-amp in higher frequency applications. We will study the slew rate in detail for AC and DC characteristics. So it is just a definition and the brief idea. So next parameter is output offset voltage. It is the voltage, it is the DC voltage available at the output of op-amp when both the input terminals are grounded. So when both the input terminals are grounded, actually ideally output should be 0 when both the input terminals, inverting input terminal is grounded and non-inverting input terminal is grounded. Then at that time the output should be 0 ideally, but practically there is some DC voltage available at the output of op-amp, and that DC voltage is called as output offset voltage, and the value is not specified in the data sheet for the output offset voltage. The next electrical parameter or performance parameter or characteristic of op-amp is gain bandwidth product. So gain bandwidth product is the bandwidth of op-amp when the voltage gain is 1. And in general for 741, gain bandwidth product is 1 megahertz. For newer op-amps, the gain bandwidth product of 4 megahertz are also available in the market. So actually gain bandwidth product is in general it is a constant. So if the gain is going to increase, then bandwidth is going to decrease, and if bandwidth is going to increase, the gain will increase. So they are opposite to each other. If gain increases, bandwidth decreases. If the bandwidth increases, gain decreases. So in that fashion, but the product of gain bandwidth is always constant. So this is about your gain bandwidth product, and the next electrical parameter is supply current. So it is the current drawn by the op-amp from the power supply, and the value of supply current is 2.8 milliampere, and it is denoted by letter I suffix S. Again, the next electrical parameter is power consumption. It is the amount of power in milliwatts dissipated in an IC. That power consumption is denoted by P suffix C, and the value for 741 IC for PC is 85 milliwatt. So this is about various electrical parameters. In the next session, we will classify these characteristics into DC characteristics and AC characteristics of op-amp. So we will see AC and DC characteristics in the next lecture. Till then, so I am going to stop here. Thank you.